Welcome everyone to Cisco ASR900 and ASR920 product portfolio webinar. We have Vinod Kumar today, who is one of our lead technical marketing engineers and will be presenting this webinar. Vinod?
Yeah, thanks, Boris. Welcome to the webinar. This webinar is going to cover a little background on the ASR900 platform and also on the 920 platform, and then we're going to talk about the new variants and then the new hardware which we introduced on the platform. So Cisco ASR900 and 920, these are the aggregation and then the access portfolios from Cisco. So we're going to cover that. Before I start off with the technical presentation, just a small bio to introduce myself. My name is Vinod Kumar Balasubramaniam. I do note the email address after my name. So if you have any questions, any queries after the session, please send out to that particular email address, and I should be able to help you with anything which is not clear or covered in the session. Right? And I'm a technical marketing engineer with the Service Provider Infrastructure business unit within Cisco. I've been primarily focusing on carrier Ethernet platform and technologies the last few years, and before that, I worked on a range of SP products and technologies the last 8 years at Cisco. So covering from CRS1, ASR900, ASIC and multiple service provider technologies as well. So that's my background. To move forward, a quick disclaimer, there are actually some products, some features that are going to be mentioned as roadmap. So if you're interested in the product or features and they are mentioned as roadmap, please do check with us before you go with the deployment. So the features and then the products which are mentioned, which are on the future roadmaps, may change based on the business priority. So please do check with us if they are on track, and we should be able to confirm it to you. Thank you. Okay, so as people who are not familiar with Cisco access and aggregation portfolio, the initial access and aggregation portfolio, so to give you just a little background, we started off with ME3400, and then we introduced ME3600, 3800 in the access space. And in the aggregation space, it's more of pre-aggregation, we introduced the ASR903. And the ASR903 is more of a modular chassis. So we have a modular variant, so ASR900, which we're going to talk about. That's the modular variants, modular portfolio variants which come under ASR900, and then the ASR920 is more of fixed variants. So the ME3400, 3600, they all evolved into next generation platforms, which is ASR920. So in the access and the aggregation portfolio, we have the modular variants, which is 920. We're going to talk about 920s, which is the current generation of access variants. And then we'll talk about the aggregation product portfolio, which is ASR900, and those are mostly the modular variants. And we're going to talk a little bit on ASR903, which was the first modular variant, and then we introduced 902. And the recent addition to that family is ASR907. So the presentation mostly focuses on the newest variant which was released, which is ASR907, and also the new RSP3. So those are the products that we're going to talk about in ASR900. And in 920, we will just do a brief overview on all the variants which are available in 920, and then we're going to talk about the newest addition which came out in August, that is the new cell site variant in the ASR920. So this picture pretty much just gives you an overview on all the products which are available today, the previous generation and also the current generation products. Okay, moving forward, ASR900. So I kind of just introduced ASR900 a bit. The modular product portfolio, ASR903, 902, and then 907. When I talk about modularity, that means that it has different interface modules that you could insert in IM slots, and it also has redundant RSP, redundant route switch processor, RSP. So 902 is actually kind of actually different. It doesn't have any redundancy in terms of RSP, but the 903 and 907, they do have it. So when we trace back, when we introduced the ASR900 series, the first RSP was 55 gig RSP. For a 55 gig ASIC, the RSP had a 55 gig throughput switching capacity within the RSP1. And from there, we actually moved to RSP2, which was 64 and then 128 gig capable. So usually we have two versions of RSPs. Even in RSP1, we had RSP1A and 1B, and in RSP2, we had RSP2 64 gig and then 128 gig. And RSP3, we actually continued the same thing. There is a 200 gig RSP3 and then a 400 gig RSP3. So when we look at the carrier Ethernet and mobile backhaul markets, that's where mostly these products are positioned. So it's really important to look at certain features, certain requirements, and then how those requirements map as the important features for these switching ASICs or for the switching ASICs which are used in the RSPs, right? The first thing is high performance. So performance is no compromise. So we need 64-byte line rate, unicast and multicast on the platform. So from the performance perspective, there is no compromise in terms of the smallest packet size, line rate, unicast and multicast. QoS features, of course, we have multiple services which are flowing through the networks, which are constructed or which are actually deployed using these products. And multiple services are terminated or actually carried through the same physical interface. So the QoS has to be really advanced. So it has to, we support a 3-level hierarchical QoS, and also the QoS is granular to such an extent where not just the QoS application on the physical interface, you could actually apply it on the logical interfaces as well, right? Layer 2 logical interfaces, we call it service instances, or they're named by EFPs as well. So service integration. So as the networks evolve, as the newer generation services evolve, so the demands of the services increase, and also there are actually new features that come in as the requirements to transport a service or to actually enable the service, right? So here, some of those features can be talked about, like crypto, like support for IPsec, and also having like a GNSS receiver capability within the platform itself. So those are some of the examples of that. And also, I mean, we cannot ignore optical features, right? So inherent support of optical features as well. So you will see that multiple, as the networks are consolidating in the service provider environment, Ethernet, optical, TDM, all these traffic are going to be carried in the same network. So you would need multiple interfaces to actually carry the traffic. And this is one of the requirements. So this is one of the requirements and one of the highlights of our platforms as well, right? Features in order to carry those different types of traffic, and also interfaces to support the different type of traffic. Moving forward. So when you talk about ASR900, so let me be clear in terms of when I talk about ASR900 and 920. 900 is aggregation, and then the 920 is access, right? If you're familiar with the service provider topologies or network topologies today. So 920 is placed in the access space, and then 900 is placed in the aggregation space. So, and what do we have in aggregation today? Like I mentioned before, there is actually a 902, 903, and then 907 chassis. So we'll go in a little more detail, talk about what is 902, what is 903, what is 907, how many IMs, how many RSPs do they have, and what are the different kind of RSP versions do they support, right? And then how many IM modules that they can take, and we can actually talk in detail. Just to give you an idea, the smallest one is the 902. And then from there, we have the 903, and then the biggest chassis that we came out recently. So you could see that to the rightmost one, that's the ASR907. And for the first time, we introduced 100 gig in our portfolio, so using 907. So 907 has 100 gig interfaces. So in your aggregation today, you can have 100 gig based aggregation network with 907. So let me move a little forward. Okay, so in the 900 series, let's talk about the first one, the smallest one that we have, that is the ASR902. 902, it's a modular platform. It's a modular platform. It's a 2RU, and it has 4 interface modules. The lines, the line cards that you talk about that are mostly actually denoted by interface modules. So when you start dealing, when you read documentation, when you start dealing with ASR900 series, they are actually denoted as interface modules. So there are 4 interface modules. The interface modules let you insert different types of interfaces, let you have different types of interfaces on the platform itself. So each slot can take different types of IMs that we have today. It can be a TDM, it can be an Ethernet, 10 gig, it can be an optical IM. So there are multiple types of IM cards that are available that you could use. It has only one RSP. There is no redundancy in terms of RSP here. There is only one RSP. So there is no real redundancy for like the control plane or the management plane here, right? So this is only 902. With 903 and then 907, we have redundancies with RSP. And an important thing to note is the dimension. So the depth, it's 9.22 inches. So it's actually less than 100 inches. It's half the depth of a rack. So these requirements, these are pretty stringent requirements when you talk about carrier Ethernet and then mobile backhaul sort of deployments, right? And apart from that standard, we have 2 power supplies for load sharing. And like I said, there is only one RSP. And the 902 came after 903. 903 was one of our first variants in the ASR900 family. The 902 doesn't support the RSP1, the first generation RSP. It supports after our RSPs, after RSP2. That means including RSP2 as well. So RSP2 and RSP3. So also RSP3, there are 2 variants. So the 902 supports only the RSP3 200. So when we get into RSP3, I'll make this point more clear, but just an FYI for now. So in terms of progression of bandwidth in phase 1, 80 gig, and then we are moving to 200 gig. That is the phase 2 is the current one, where with the RSP3 we're moving to 200 gig, and then in the future we'll look at moving it to 480 gig on RSP2. So the backplane is capable. So that's actually one of the points I want to put across when we talk about multiple bandwidth evolution. The backplane is capable to migrate from one phase to the next phase, depending on how the bandwidth requirements change or increase, right? So you just have to actually change the RSPs. That's about it. Just replace RSPs in order to support a higher bandwidth through the box or higher throughput through the box. Okay, that was much about 902. Let's talk about 903. 903 was, like I said, that this is our first variant in the ASR900 family, right? So in terms of size, the height, do actually make a note of 902, 903, the last digit, because that really determines like how tall the platform is. The 902 is 2RU, the 903 is 3RU, right? 3RU. Now, how many IM or line card slots that do we have? So we have 6 line card slots, whereas in 902 it was only 4. And here we have 2 RSPs. We have control plane redundancies. There are two RSPs here. And from the power supply wise, there is actually 2 power supplies in the bottom to provide redundancy. And again, in terms of depth, so the depth is the same across all the ASR900 portfolio. So 902, 903, the bigger chassis 907. So even with the change in form factor, even the chassis has gotten significantly bigger and more powerful with 907, but the depth is still 9.22 inches. We haven't actually moved away from the depth. When I get to 907, I'll actually emphasize that point. So since 903 was one of our first, it was not one of our first, but it was the first variant in the 900 family. So the first RSP1, which was 55 gigs. So we had 55 gig first RSP there. That's the reason we start off from there. The 903 today, the deployments, when you see, we have RSP1, RSP2, and RSP3. All the 3 generations of RSP are supported on 903. The first one was 55 gig, and then the second RSP2 was 128 gig, and then the RSP3 is 480 gig. So when I say RSP1, 2, and 3, I'm talking about RSP first generation. RSP1 is the first generation. RSP2 is the second generation. RSP3 is the third generation, so the current generation. So 907, as you can see, a label on the top, it's actually the newest variant in the ASR900 family. And so this was, we started shipping this about 2 months ago, end of August. So this has 16 line card slots. So 8 in the bottom, 8 in the top, and then you can see there are 2 RSPs in the middle. We'll get to a bigger picture. I'll explain this better. And then we have 2 RSPs for redundancy sake. And talking about the dimensions, like I said, the depth, it's we maintain the same depth, 9.22 inches. And with the 907, we have an advanced, we have higher throughput backplane. So the first phase, the first phase of RSP, the first phase is going to be the RSP3. So from here, the generation of the RSP start on the 907. So the 907 doesn't support the older generation of RSPs, which is RSP1 and RSP2. So RSP3, it is capable of 480 gigs. So that's the reason we start off with 480 gigs. And phase 2, we are looking at 800 gigs. And then phase 3, we are looking at 1.6 terabits per second. So again, what does it mean? That means that the backplane is capable of more than 1.6 terabits, so it's actually 2.1 terabits per second. So you don't have to change the chassis. There is no physical. You don't have to change the chassis physically when you need to upgrade the throughput through the platform itself. The backplane, the chassis supports up to like 2.1 terabits per second, at least for the next 2 generations you're covered with 907. Okay, so I gave a lot of points on the chassis, but some of the important highlights, some of the important points which stand out on the ASR900 system. Redundant hardware and software. So we use redundant RSPs, and then the redundant power supplies, and also the fan trays. They have redundant fans inside the fan tray. So the hardware is redundant across all the parameters that you can think of. And the software, we use an iOS XE operating system. So iOS XE runs a redundant iOS process as well. So we use redundant hardware and then software. We are covered with high availability in all the different layers. Small form factor and hardened. So when we talk about ASR902, 903, they are small form factor. Right, 907 is obviously bigger, but when we talk about depth, and the density that the box can do, even with 907, when we talk about it, so it relatively occupies a smaller space when compared to the capability of the box. Optimized for aggregation of converged networks. So I made a point about how the networks are converging. So if you have multiple types of traffic which needs to be carried on the network, right, TDM, Ethernet, optical. So you could design a single network using 907, 920 to carry all the traffic. So you don't need multiple networks. So this is again basing not just on the fact that we support multiple interfaces, but it's also on the software as well. The software has multiple features, like the features that we support on the software that runs on these platforms is like huge. We support TDM, we support Ethernet, we support MPLS, layer 2, layer 3 VPNs, and also optical. So optical-based features. So there are actually multiple types of features that are supported in the software. So software is actually pretty versatile, right, in terms of carrying multiple types of traffic, right. Designed for longevity, we talked about 907. So 907, there is support for next 2 generations, excluding the present one. So including the present one, 3 generations of RSPs can be supported on the platform. So in terms of longevity of the platform, so customers have 2 more cycles of upgrade left, so they don't have to change the chassis for the next 2 generations of the RSPs. Based on iOS-XE, so I talked about iOS-XE a little bit when I talked about the software. Cisco APN Manager, we use Cisco APN Manager for monitoring, provisioning, and also when we talk about non-sub availability and manageability, so APN Manager supports ASR900. That means that any hardware-related manageability features are also taken care of by a central management tool. Okay, now focusing on the 907 platform, right? So it's a 7RU, and I'm going to just go through some of the important information here. I've already highlighted some of it. So like I mentioned before, 902, 903, 907, when you focus on the last number, the last number actually tells you how big or how tall the platform is, right? The 907 is a 7RU based platform. When we talk about the depth, so it's like 9.22 inches deep, and operating temperature -40 to 65 degrees centigrade. So we have redundant power supplies, fans, and RSPs. ISQ support capability. It's modular, we have obviously you can use multiple IAMs or different types of IAMs on a single platform itself, and it can be field replaceable, and you can actually remove or change the IAM modules while the router is in service. And when we talk about the manageability, it's important to note that most routers they have like the console, aux, out-of-band management. Those are the standard ones. With the 907, we also have a USB port so that you can connect an external storage to copy data from or to the 907 to the device. There is 4 dry input contact port on the fan tray. And also in terms of when we talk about the scalability, right? So one of the important points that I would like to make is going beyond like 12, 10 gig interfaces was not a possibility given the throughput of the previous generation RSP. But with the current generation RSP, we can go up to like 48, 10 gig interfaces. So in terms of scale, in terms of the density of the interfaces, we have taken a big leap with RSP3. And RSP3, it can the throughput is up to 400 gigabits per second. So when we talk about RSP3, I'm going to actually talk about the different versions of the variants in RSP3. There is a 200 gig and then a 400 gig. But 400 gig, that's actually the maximum throughput that is available in RSP3 today. And by using a 400 gig based RSP3, you could literally have 400 gig line rate traffic switching through the system. 64 bytes, again, like I mentioned, performance is an important criteria. And feature rich. So I mentioned about the features before. The features kind of actually coincided with the network convergence, right? When we have to transport multiple types of traffic on a single network, so the software that is used on the network on the platforms, it need to have those many features, right? Supporting the transport of multiple different types of traffic flows or traffic services. So you will see me actually making this point again and again with even 920 as well. So within Cisco 900 and 920, they are kind of actually a little unique because the amount of features that we support. We have switching capability, layer 2 switching capability. We support bridge domains, right? We do G8032, we do rep. And also on top of that, we do layer 3. I mean, not just layer 3, not just like OSPF, ISIS, or BGP, but we support like MPBGP, MPLS, IPFRR, 6P, 6VP, and remote LFA. So all the advanced features in MPLS is also supported. And then we are not forgoing off the legacy protocols like TDM, like we support TDM as well, and TDM transport over MPLS. right? And since we have these multiple services going through the traffic from multiple services switch through the platform, so we need to actually support good QoS, right? So QoS has to be really strong. So that's the reason the QoS feature set that we have, we always mention it as advanced QoS. Because we do 3-level hierarchical QoS in order to give good flexibility in terms of matching, and then in terms of actually giving the proper priority to the multiple services traffic that come in on an interface, and also the granularity of QoS, right? So where you can configure, not just on a physical port, but also you can get down. Like every customer, there will be multiple customers coming in on a physical interface, and every customer can get their own QoS policies, right? That's what I'm talking about. And OAM, so we cannot forgo off OAM since it's a carrier Ethernet mobile backhaul specific box like Y1731, IPSLA, CFM, Link OAM, and we do MPLS as well to transport the traffic coming from the downstream customers all the way to the remote access node or the remote aggregation node. So we need MPLS for that. So MPLS OAM as well. So, so moving forward, when I say feature rich, I'm re-emphasizing the points here. So all the features that are required to converge multiple networks. So we have it in one platform. So that's the reason we actually name it as feature rich box. And like I said, you can run layer 2, you can run layer 2, layer 3, MPLS, and TDM, and also optical on the same box or on the same network today, when the network is actually designed using ASR900 and 920 series platforms. Okay, so quickly some points on the platform introduction. I've gone through the depth. I've gone through the backplane bandwidth. So that's actually a little more than 2 terabits. It's actually 2.1 terabits per second. 16 IM slots, right? Interface modules are reusable across 902, 903, 907. So another point here, when I introduce 920, you will see that 2 of 920 variants have the IM slots. So the interface modules here, not all at least, but some interface modules can be reused across 920, 902, 903, 907. So it's actually the same interface module which goes on all these platforms. So obviously, the newer RSP3 has more throughput, so there is actually high density 10 gig, 100 gig IM modules which will not be actually supported in 920. But the IMs that are used between all these variants, that is the 920 and the 900 variants, are going to be the same. So when I go into more details on RSP3, so you're going to see that there are 2 different variants on RSP3. One is like wider form factor, and another one which is smaller form factor. So when we actually look at the pictures of 903 and 907, 907 has a wider RSP slot, so that means a wider RSP3. Whereas the 903 has a smaller RSP slot, so it needs a smaller RSP3. So that's where the form factor comes into play. But other than that, the hardware, the ASIC that we use within both the RSPs, both form factor RSPs are going to be the same. So there is no difference between the 2. And with the introduction of 400 gig based RSP3, so we have taken a big leap in terms of the densities, the port densities that are supported on the platform itself. With the introduction of 100 gig, so you need more, like if the 100 gig becomes like the upstream interfaces or upstream links, downstream you need more 10 gigs and 1 gigs, right? So the new IM modules that we are introducing with the RSP3 are 8-port 10 gig. It's SFP plus based. And the 8-port 10 gig, it can do dual rate both it can do dual rate both 1 gig and 10 gigs. Currently, we support only 10 gig. 1 gig is on the roadmap, so I will actually cover that information in the future slide. And 100 gig, it's actually a CPAC-based IM. And also, we are introducing, end of this month, 2-port 40 gig, right? So some customers, they find it a big leap going from like a 10 gig to a 100 gig based network. So for them, they would have to actually look at something intermediate. So we are actually introducing 40 gig as well to help customers smoothly migrate or actually kind of actually take it step by step when they're migrating from 10 gig to 100 gig. Obviously, the RSP3 with more throughput, it needs more power. So the new power supplies, it's 1,200 watt power supplies that you would need for the new RSP3s. With ASR907, it supports only RSP3, so by default you get that. But when you're migrating or when you're upgrading a 903 to an RSP3, right, then you would need to actually think about upgrading the power supplies as well. There are certain conditions when you would need to upgrade the power supply and when you don't need to, so I'm going to go through that. But just a point here that you would need newer power supplies with RSP3, and we've introduced newer power supplies with RSP3 just to meet the power consumption demand. Okay, so finally, a lot of talk and not clear or bigger pictures of 907. So here you see the 907 chassis in the entire slide pretty much. So talk about how the modules are kind of housed in the chassis, right? In the middle, you have two RSPs. So there are two RSPs, one RSP on the top, one RSP in the bottom. And on top of the RSPs, you see 8 IM slots. So and in the bottom of the two RSPs, you see the remaining 8 IM slots. So there are total 16 IM slots in ASR907. And there are 3 power supplies all the way down below, and all the way towards the right, you will see a fan tray. So that's a fan tray. Now, the GPS GNSS receiver, it's a small slot, right? The slot is on the RSP, so you could see a red pointer pointing on the GPS and GNSS. It's a small module. You just have to screw it into the RSP, and then you're good. You can connect a GPS antenna directly to the RSP3 or to the platform itself. That's pretty much it. I'm going to just give you a minute to kind of actually look through the diagram once, kind of digest the picture, but it's pretty simple. The RSP is in the middle, and then you have IM slots on the top and then the bottom, and then you have the fan tray on the right side, and the power supply is all the way in the bottom. Okay, so what did we introduce with the 907? I talked about RSP3, I talked about the IM, so just actually kind of reiterate those. The RSP3C400S, that's actually the small form factor RSP3 for ASR903. The last letter S should actually give you that idea. When the PID, when the product ID says it's actually an S, when it has an S in the last letter, that means that it's actually a smaller form factor RSP3 that's used in 903. And the same way, the RSP3C400W, that's the wider form factor RSP3 that's used in 907, increases capacity to 400. There are 2 variants in RSP3. One is 200 and 400 gig. We are not shipping 200 gig yet. That's coming up shortly. We are shipping 400 gig right now. It delivers integrated GNSS receiver. So in the previous slide, we saw that the GNSS receiver could be just screwed in or plugged in into the RSP directly. So you need in certain customer sites, if you have a 907, you don't need an external receiver at all. The antenna can be directly connected to the RSP3 or 907. 3 new IMs were introduced. 100 gig. This is the first time we are introducing 100 gig in the aggregation portfolio. So 100 gig, it's a CPAC base, and 8 110 gig. So like I mentioned, the 8 port 110 gig. So this IM really helps to scale our 10 gig density, and I'm making this point again and again because one of the highlights of 907 has been most customers they talk about how the platform really improves or really improves on the 10 gig density, right, when compared to the previous generation RSPs, right. And also for customers who want to migrate step by step from 40 to 100 gig, we have a 240 gig QSFP based IM as well. Okay, so 1200 watt power supplies. So do keep in mind today we are shipping DC power supplies. AC power supplies are going to be available in 318, which is next March, that is 2016 March. And the power supplies operate in completely in a redundant manner. The 902, 903, they all have 550 watt base power supplies today. So with 903, if you're going with two RSP3s, like one active and then one redundant, so only when you go with a redundancy-based configuration, then you would need to upgrade the power supplies to 1200 watt. That is a new power supply. If there is only one single RSP3 in there, then you could stick to the older power supply, which is a 550 watt, and you could actually pretty much power the entire platform with the older power supply. So that's the only catch there. The newer power supplies, obviously, since we do more traffic, more throughput, the consumption is a little higher. So only when there is a redundancy required in terms of RSP3 on 903, that's when you would need 1200 watt base power supplies. Fan tray, not to actually drag here, but you could see that there is only one fan tray, but there are 12 redundant fans within the fan tray. So it's not that there is no redundancy in the fan system, but the redundancy is built within the fan tray itself with multiple fans. Okay, so we talked about the RSP, we talked about the power supplies, fan tray, then what is left over? The IM modules, right? So some important points on the IM modules itself. 100 gig, pretty much a very big, very big, I would say, very big IM module, very big instance in terms of the traffic, which is actually carried through the IM. It works on RSP3 only. It doesn't work, it's not backward compatible with RSP2 and then the RSP1. So naturally, because of the throughputs that RSP2 and RSP3 supports, and the current CPACs that are available are LR4 and SR10. The remaining, which are mentioned, are coming out like mid next year. And it supports DOM, MTU sizes up to 9216, those are the standard ones. And the important thing is we support synchronous Ethernet in and out on the IM module. So timing is actually a pretty important thing in mobile backhaul networks. So that's the reason I'm emphasizing on SyncKey. Two-board 40 gig. Again, not supported on RSP1 and RSP2. It works only with RSP3. So LR4 and SR4 we are shipping today, and the remaining ones, ER4, LR4, SR4, are coming out early next year and then mid of next year. And there's no difference in terms of DOM, MQ size, and then the synchronous Ethernet. It's actually the same. The 8-port 10 gig, so I kind of actually mentioned this before, gave a little background how 8-port 10 gig really increases the 10 gig density on the platform today, or on the whole portfolio of ASR900 today. So this is supported on RSP3 only. Obviously, not it doesn't work with RSP1 or RSP2. It's SFP plus based, and it supports DOM, MQ, sizes 90 to 16, and synchronous Ethernet in and out. I made a comment on the dual rate. Only 10 gig is supported today. Only single rate 10 gig is supported today. 1 gig will be supported in the future. So that's on the roadmap. Okay. So when you use RSP3, what are the different combinations that you can have with the IMs, right? So the different combinations that you can have with the RSP3 400 IM is 20 into 10 gig plus 2 into 100 gig. So do keep in mind it's a 400 gigabits per second throughput on the RSP3. So we limit the interfaces to 400 gigabits, right? So you cannot go beyond that. We are planning to support like oversubscription. So I would like to be very clear on what oversubscription is. We're not going to have any kind of intelligent way of dropping the traffic within the system, right? So all we're going to do is if you're not running all your links 100% hard, then you can have more interfaces on the chassis, that is interfaces more than 400 gigabits. And the traffic which is coming in, if it's within 400 gigabits, then there will be no packet drop. So if it goes beyond 400 gigabits per second, then you will see random packet drop. So that's actually that's the point that I wanted to get it across. So oversubscription in terms of interfaces we're going to provide. So not in terms of actually dropping the packets intelligently within the platform itself. So coming back to the combinations, 20, 10 gig, 200 gig, or we can have 16, 10 gig, and then 200 gig plus 18, 1 gig. So if you are familiar with the access platforms or access or aggregation portfolio, so when was the last time you saw like an 81 gig, right, or 10 gig? So when we actually get to RSP3 and also the next one, when we get to the 903, the next point, you can see that you can have a combination of 20 10 gig interface plus 200 gig, or you can have a 48 10 gig on an RSP or on an ASR903, right? Just 48 10 gig. So when was the last time you saw 48 10 gig interface on the access and then the aggregation portfolio? So that's the reason I was emphasizing on the interface density when I talked about RSP3. So really, in terms of scaling 1 gig and 10 gig, and with RSP, with ASR907, since you have 16 IM slots, so there is a lot of scope in terms of actually expanding those port densities, be it 1 gig or 10 gig. Obviously, 100 gig you're just limited to 2 because the whole throughput of the RSP3 itself is 400 gig. So RSP3 200, right? So there are two variants of RSP3. One is 400 gig and 200 gig. So I was talking mostly on the 400 gig. So just kind of actually, I want to dive down and talk about RSP3 200. The RSP3 200 is going to be supported on 902 and 903 only. It's not going to be supported on 907 with 16 IM slots. I mean, it really makes sense that you have a bigger RSP3, 400 gig RSP3 on 907, right? All the previous IMs will be supported, and also do keep in mind the RSP3 200 is not shipping today, so we'll be actually shipping it shortly. So 400 is the only RSP3 which is available today. In terms of CPAC, 100 gig CPAC technology is currently limited to 55 degrees centigrade. People who are actually a little particular about the environmental parameters within the deployment site. So this is one thing to be aware of. So I touched upon oversubscription a little bit because I wanted to make sure I really intend to put across what oversubscription would mean going forward on the platform. With RSP3, I mentioned that we have 400 gig and the 200 gig. So there is the internal architecture of 400 and 200 gig varies only with an addition of another ASIC. So the carrier Ethernet ASIC today in RSP3, the internal switching ASIC, we call it carrier Ethernet ASIC because when we talk about ASICs, right, the ASICs are built based on the requirements in a carrier Ethernet or a mobile backhaul network today. So the carrier Ethernet or a mobile backhaul network, as I said, they have requirements ranging from carrying multiple different types of traffic, CDM, optical, Ethernet traffic, and also there is a requirement of timing as well in mobile backhaul. So the ASIC is designed keeping these carrier Ethernet requirements in mind. That's the reason I'm actually frequently substituting the name of the switching ASIC as carrier Ethernet switching ASIC. So the carrier Ethernet switching ASIC that we use, it's actually one single ASIC which can do 200 gigabits per second. The RSP3 just uses one single ASIC. The RSP3 200 uses one single ASIC. The RSP3 400 uses two ASICs, right? That's how we double the capacity to 400. And just to give you some details on the on the power of the ASIC itself. The ASIC can do 260 million packets per second. So the ASIC is capable of doing more than that. So today it's enabled for 260 million packets per second. In the future, we will actually go beyond, and then we'll enable 300. The switching ASIC can go up to like 300 million packets per second. So I talked about the oversubscription and also the oversubscription, how we can achieve it. Like the 2 points, the 3 points actually kind of cover that. And also I talked about how we actually do a non-intelligent way, right? So it's not going to be an intelligent way of oversubscription. So I covered that previously. So I'm going to move forward to the next slide. So talking about the ASIC, I kind of actually talked about the carrier Ethernet ASIC, the ASIC that we use internally, right? And the requirements that dominate I would say more of it, the requirements are dominated by what the mobile backhaul networks and then the carrier Ethernet networks actually want from a platform, right? So to put it in a way, the major highlights of the ASIC are dominated by the requirements from the carrier Ethernet and the mobile backhaul network, right? And like I just said, it's a gamut of features that carrier Ethernet and mobile backhaul networks need, layer 2 switching to layer 3 MPLS, advanced QoS, and also timestamping, because we need to do timing, right? There is timing support as well. So keeping all these things in mind, right, the carrier Ethernet ASIC packs up actually really, I would say it packs up really good power in terms of performance, and it also packs up good convergence features as well, right? So we are able to do a BFT at 3.3 millisecond that helps us design fast converging networks as well. And another important point is buffer size, right? So since we have multiple types of traffic, so we need to make sure that different types of traffic get proper SLAs. So we need deep buffers. And you could see that we have 4 gigabytes of buffer on RSP3. We are taking a really big leap, right? The 16 MB is just an internal buffer with the ASIC, but we have an external buffer, 4 gigabytes. So one of our first platforms in Access, the maximum buffer that we went with an external buffer was around 352 megabytes with ME3800. And then with the remaining ones, we were sticking with the internal buffer, right? With RSP3, 100 gig coming in, and then the port density going up, like the 10 gig and 1 gig port density going up, we really kind of went pretty aggressive on the buffers. And like it's mentioned in the slide, it's 4 gigabytes of buffer which is available on RSP3 today. Okay, just to give you some comparisons of the different generations of RSP, the RSP1, 2, and 3, the 3 being the newest one. So the RSP1 was 55 gigabits per second full duplex and 65 million packets per second. RSP2 was 128 and 128 gigabits, and then 180 million packets per second. Again, in RSP2, we had a 64 gigabits version of RSP and then 128. And with RSP3, we have 400 gigabits per second and 600 million packets per second, right? So remember, I talked about how the ASIC is capable of doing 300 million packets per second, but we haven't still enabled the full capability. So that's where the number 600 comes from. And at 400 gigabits per second, we have 2 ASICs and 300 million packets per second, just multiplied by 2 for 2 ASICs, and then you get that 600 million packets per second. So scalability, so when we get to the scalability part, I think it will become more obvious how we have actually taken a big leap in terms of scalability as well with IPv4 routes, MAC address table, and all those things. So when we get there, we'll actually, it will be more evident how the scale has actually gone really high with RSP3. And let's skip the IAMs because I talked about the IAMs. All the new IAMs are supported only in RSP3. I talked about the crypto feature, right? Embedding new services into the hardware itself. So We have crypto services like ASIC, which is actually done in the hardware itself, and we can go up to like 5 gigabits per second of throughput when we encrypt or decrypt an ASIC-based traffic. So that's actually one of the important highlights as well. So as the networks are evolving, newer features and then newer things have to be done in the hardware to keep up the performance and then the latency. NetFlow support, we supported in RSP2. We are actually keeping that in RSP3 as well. I'm talking about the capabilities. Do keep in mind that the hardware is capable. If the implementation is there or not, that will be dominated by the roadmap. So that's the reason there is actually a star symbol there, which says that it's still not there, but the hardware is capable and that we'll be implementing it in the future. Timing, so naturally we have supported good timing features, so frequency, phase, time of the day, be it in RSP1, RSP2, and RSP3, or we have good timing feature set. We have in fact lived up to that expectation. GPS receiver, RSP1, RSP2, it was an external one, and then we have incorporated it as a module in RSP3. So these are some of the important highlights or capability differences between RSP2 and RSP3. Of course, I mean, when we talk, there is no mention of the 10 gig and then how the 10 gig and 1 gig can be scaled here, but that's an additional advantage as well. So RSP3, quickly just to go through on the left side, you see 4 golden pins. Those are the timing. Those are the timing ports, and you can see a small. Following that, there is actually a small module. That's the GPS or GNSS module. And we have the console port following that, and then we have the console port USB, and then we have the console serial port. And also we have the USB flash port. Following that, there is a serial time of the day port and also the USB flash port. The USB flash port was the one that I was mentioning where you can copy from and to the device. And we have the out-of-band Ethernet management port. And we have the bits interfaces following that, and also the LEDs to let you know what is the status of the RSP, if it's bad, good, is there any warning. So all those things are going to be denoted by the LEDs, which are shown on RSP. So it's a pretty standard, right? I mean, apart from our timing pins, right? So you would see most of these interfaces in most router or switch platforms. Same thing on the RSP3C, that's the smaller form factor. Not to go in detail, but the interfaces are pretty much the same. They are actually rearranged here and there just to make sure they make use of the real estate well. 200, there is no difference there. Like I said, only internally we have one ASIC, one switching ASIC when compared to 2. That's pretty much it. But from the external ports wise, it's the same. There is no difference. Okay, so talking about the internal architecture, 400 gig, we have 2 ASICs. So you can see ASIC 0 and ASIC 1 and how the IMs connect to it, right? This is, I just wanted to put it across so that you get an idea. And we have the RSP3C 200, we have only one switching ASIC. The switching ASIC is capable of 200 gigabits per second. So that's the only difference in terms of the hardware. And these are some of the memory parameters that you need to be aware of, and not that it needs to be discussed now. But do keep in mind that it supports up to like 8 gig flash, so you can use an external USB in order to connect to copy data in and out of the device. I'll leave the compatibility matrix. This is when you're doing a deployment, so where the IAMs need to be inserted with slots. So it's more of a compatibility matrix. It's nothing got to do with going in detail and explaining. So when you order a Dyno 3, obviously the configurator tool will guide you through some of it, but this is like a data site where you need to make sure you go through it and then you understand what IAM slots can be actually inserted in what IAM slots. So this talks about like multiple RSPs and also all the different variants that we have, the 902, 903, and then the 907. So I will leave it as a data slide. Do actually keep in mind some of the IAMs are not supported today, so they're coming up in the roadmap. So do carefully look at the star mark there, and then you get an idea of what is supported, what kind of IAM modules are supported today, and then what kind of IAM modules will be supported in the future. Okay, so that's actually the conversation that's giving you more of a deep dive into RSP3 and 907. Now we're going to actually close the section out with scalability and the roadmap section. So scalability, when you compare with RSP1, obviously 1B, we had an external TCAM, so we actually really increased the scale in RSP1B. But afterwards, in RSP2, we really wanted to actually work on minimizing the hardware, I mean, because of the competitive nature of the market, right? So in RSP2, we have 16K MAC addresses, but with RSP3, we actually went from 16K to 250K. Right? At FCS today, we support 200K, but the RSP3 has the capability to go to 250K, which we have it on the roadmap to be supported as well. So all the other ones, like the EFPs, we support around 5,000 EFPs for the entire system. Number of MAC addresses in the bridge domain is 64,000. All these are data points. I think one of the important ones is Ethernet over MPLS pseudowires. So Ethernet over MPLS pseudowires, we doubled it to 8,000. In a carrier Ethernet-based deployments, the Ethernet over MPLS pseudowires have become a common scale parameters to be verified. So just highlighting that. And when we move to layer 3 scalability, the IPv4, we went up to like 128K. The previous generation RSPs, we were at 20K, and then we took a big leap to 128K. And the OSPF has BGP enables, right, from the control plane perspective, right? So you can go up to like 400 enables combined OSPF, ISF, and BGP, just to highlight the control plane bandwidth, right, in terms of handling the number of sessions. All the other things, I'll just leave it as a data slide for you to go through. And the BFD sessions, this is actually important. We have an external FPGA doing BFD. So 3.3 milliseconds, we do 1,023 BFD sessions. This is an important thing to keep in mind. And also when we jump onto the CFM sessions, right, so there is actually 1,000 CFM sessions that we actually support on the platform itself. So these parameters are some of the important ones that I've come across when we deal with the deployment of the platforms. But there are multiple other parameters for you to actually refer. QoS, 48,000 per system in terms of queues. That's actually a big leap in terms of where we were with RSP2, which is 8,000. And policers also, we went to like 24,000. So just some of these are some of the parameters to keep in mind. And I'll just leave the other fields or the parameters for reference perspective. And even this one as well. So just to make sure I utilize the time efficiently, we are already on top of an hour, and I have another 30 minutes to wrap up 920. So if there are any questions on the scale, do get back to us. I'll be glad to answer any questions that you have on scale. And also software roadmap. So I'll put it across as a data slide right now, just for you to go through the software roadmap. Everything has been clearly documented. Just nitpicking any features here, discussing it might not make any sense. We have only one IOSXE release for the RSP3. This is RSP2. I'm just actually displaying both RSP2 because since we have active development done on RSP2, and with RSP3, the first release was 3.16, which was like 2 months ago. And the next release, 3.17, is end of this month, and then 3.18 is actually early next year. So you can see that there is a huge focus on VPLS on the 3.17. We're trying to close the gap in terms of the solutions which these chassis are being deployed today, like a layer 2 or layer 3 based solutions. So this actually marks the end of ASR900 sessions, right? And like I said, I just ran through the slides for the scalability and then the roadmap pretty quickly because those were more of the data or a reference slide. So if you have any questions on those, feel free to shoot an email. So we talked about the ASR900 portfolio, right? And then now we'll jump into access. We will move from service provider aggregation to service provider access. In service provider access, 920 portfolio is actually Cisco's answer to access deployment. So 920 has multiple variants as such. So there are a couple of important things that need to be understood when we talk about the variants. So we have a single OS and then single ASIC across all the variants, and this is not just with 920. With the RSP2 on the ASR900, it uses the same ASIC and then the same operating system as well. So in order to speed up feature velocity and also in order to improve the quality of the products that we ship, so we kind of went with a consolidated approach where we have single switching ASIC, I would say single hardware because it uses the same FPGA, and then internal hardware things. So the RSP2, 64, 128, and the ASR920, they use the same switching ASIC. So the kind of point that I wanted to put it across is having a single OS, single ASIC helps us to actually develop features in a faster way and also test our boxes in a faster way as well. Breadth of product portfolio, so you can see that we have variants ranging from like 4-port to 12-port to 24-port to a 24-port based IM and also a passively cooled box. So there is actually a lot of product breadth, right, depending on multiple deployments you have, like be it MPLS NID, be it a smaller port density access to a high port density access to actually a converged access like TDM, 10 gig, 1 gig, right? So you can use ASR920 just, and you may have the requirement in, you may have like a TDM requirement in certain places, you may not have a TDM requirement in other places. So you can have pretty much the same hardware, like one single ASR920 system across the network, right? So even if there is actually varying demands for interfaces at different places. Compact, it's a small form factor. It's a 1 RU. Most of the units are 1 RU. There is a 1.5 RU platform as well. So the 1.5 RU is because we have an additional IM module just to give flexibility in terms of interfaces that you can have on the platform. And the passively cooled one is obviously because it's a 2 RU platform. And advanced carrier Ethernet and mobile backhaul DNA, this goes back to the gamut of features that we support, just like what I talked about in ASR900, TDM, Ethernet, layer 2, layer 3, MPLS, timing. So all these features are supported. And network convergence also goes back to the same point. Since the portfolio, since we have a big breadth of portfolio with multiple variants, and also we support multiple features on the platform. Network convergence is enabled. That means that you can use one single platform or product portfolio to deploy it across your network with varying demands. Okay, so enough of talking, and then now with a bigger picture on 920, what are the different variants that we have on 920, right? So let me start off from the left. On the left, we have the 4SE, ASR920 4SE. That's actually a 4-port 110 gig SFP plus based port, SFP plus based ports, and we have a 2 copper port, right? This is the smallest form factor or the smallest variant that is available on 920 today, and then it's used mostly for like an MPLS NID or a 10 gig NID based deployment. And then following that, the ASR920 12 CZ, A and D, both AC and DC version. It's 12. There are 12 GE ports, and there are actually 8 ports which are like combo. You can use copper or SFP, and then we have 2 110 GE, that is dual rate SFP plus. And there is a passively cooled one, the ASR920 10SC PD. That's a passively cooled device, right? And after that, we have the high port density variant, the ASR920 24 TZ. It has 24 1 gig copper, and then 4 10 gig only interface, that is SFP interface. And then the ASR920 24 SC, It's again a 24 fiber GE ports and then 4 10 GE only SFP based ports. And the ASR920 24 SCIM that again has an additional IM module on top, and it has the same type of like fiber interfaces as 24 SCM, right? So we just take the 24 SCM and then we put a IM slot on top of it. So IM slot again, it provides you some kind of oversubscription, and again we are talking about the non-intelligent way of oversubscription, like I mentioned before. And this gives you flexibility of introducing like TDM interfaces of the same platform, right? If you have a low TDM, low port TDM, low port density TDM requirement, you could actually use the platform. And it can go up to like 32 even ports as well. So I wouldn't really call it low. So I would really say it from low to medium to high, depending on how you quantify low, medium, and high. And the last one, ASR920 12 SCIM, that's like our premium box, right? That's mostly used in cell-site router-based deployment. So we're going to talk about that box that was recently introduced in August. Okay, just to kind of actually go through some of the important points of 920. So I'm going to just go through each variant and then just talk a little bit about it, and then we're going to jump into the newest variant of 920. So since 920 has been shipping for a year and a half now, I'm pretty sure most of you would have heard about it, or at least actually got to know about it. So the most popular variant, ASR920 12CZ, right? Like I mentioned, let me actually jump over to the bigger picture here, right? So it actually makes it more comfortable to explain, right? So we have power supplies on the left. Do keep in mind that power supplies are not replaceable, right? They are actually redundant. There are redundant that you can see the power supplies are redundant, and even the fan tray in the back, it has redundant fans within, but they are not replaceable. It's a fixed power supply and fixed fan tray unit. And we have the timing 1 PPS bits. I'm not going to go into the management interfaces. We already went through it. We talked about a little on the ASR900. It pretty much follows the same suite. Apart from that, you have some additional USB console and like and then RS-232 console. There are some additional interfaces, but that's pretty self-explanatory when you actually go through a CCO guide. So just focusing on the important things, right? So what are how many interfaces do we have? We have 12 GG SFP-based interfaces, and then we have 8 copper-based. So again, it's combo. That means that you can, for 8 of the ports out of 12, for that 8, you can use either a copper port or a fiber port. So that's essentially what the combo means. And there is, following the GG interfaces, there is actually 2 SFP plus. That's a dual rate, again, 1 GG or 10 GG, right? You need a license to upgrade it to a 10 GG, otherwise they'll be functioning at 1 GG speeds. Okay, so we talked about the 12 port and all the parameters which are mentioned there: compact, reliable, flexible, scalable, right? So all those parameters are the same, right? So I'm going to actually touch upon it right now, right? Since I actually didn't touch upon it before. It's again 1RU, the depth, right? We're talking about the depth. The depth is a little more than 10 inches, so we actually still stick to the half rack depth. And the power supplies, I said they are actually fixed, so but there is redundancy in power supplies, and then there is redundancy within the fan tray itself. And since we have the same ASIC, the features, right, so layer 2, layer 3, when we talk about scalability in the bottom, the last point, the layer 2 feature, layer 3 features, the MPLS features are all going to be the same. There is going to be some difference in the feature set, but that's going to be very small because some of the only 2 of the variants that support TDM, so there will be TDM features on them which you will not see on the other platforms, right? And then there will be actually a change in timing features. Like, for example, this doesn't support 10 megahertz. The other variant supports, that is the 24-port variant supports the 10 megahertz, right? So there will be some small changes like that, but when you look at from the feature perspective, there is a parity across all the variants of 920. So now the compact model, right? So focusing on the important things, like I said, there is 2-port copper GIGI, right? So you could see that it's clearly marked, and then following that, there is a 4-port 110 GIGI SFP plus with dual rate. Like I said, this is our smallest variant, and this is mostly used when you need MPLS all the way to the NID, or mostly when you need like a 10 gig NID, right? So those are the scenarios where you would deploy it. Okay, so talking about the 24-port, this is the high port density platform. I'm not going to touch upon the parameters on the right side because it's going to be almost the same. There is no difference, right? In the 24-port, couple of differences. Power supplies are replaceable, redundant are replaceable, fan tray, they are replaceable, and we have 24-port GIGI, and then there is 4-port 10 GIGI SFP. So the 4-port 10 GIGI, they are not dual rate, they are only single rate ports. So just keep in mind, all the lower port density variants like the 12-port and then the 4-port that we talked about, they can do dual rate on the 10 gig ports. So here there is only 10 gig on the 10 gig port, so you cannot do like 1 gig, right? If you don't have the license, then pretty much those ports are going to be in downstate. They're not going to come up. So 24-port, adding up to the 24-port when somebody needs a flexibility to introduce CDM interfaces, right? So we came up with another variant which has an IM slot. So the IMs that are being used here, they can be used between 902, 903, 907, right? I mean, not all the IMs, certain IMs, of course, right? So, but the IMs are actually switchable between 920 and then the ASR900, right? So what are the IMs that we support, and then we will be supporting 8 GIGI. If somebody needs copper-based interfaces, you can use an 8 GIGI RJ45. There is 10 GIGI XFP for oversubscription, 2-port 10 GIGI, it's a SFP plus based. The 1-port 10 GIGI, that's the only WAN-based XFP that we support on 920. And then the TDM, we support 8 T1E1, 16 T1E1, 32 T1E1 is also coming up, and 4-port OC3 and then OC12. So 4-port OC3 and OC12 are also coming up shortly. So passively cooled, nothing much to add here. Is the same platform. The configuration here is we have a 8-port 1 GIGI SFP. I think here it makes sense. The left port 8-port 1 GIGI SFP, and we have 2 1 GIGI copper and then 2 SFP plus 1 gig 10 gig, right? So this is not an IP65 compliant box. The enclosure is offset of the IP65 grade, but you can still see that the interfaces are open, so it has to still go into an IP65 enclosure. That's the reason we have clearly actually named it as a passively cooled, not like an outdoor unit, so to keep in mind. Okay, so talking about 920, the newest variant that we have, the ASR920 12SE-IM, right? So let's actually talk about the platform. So what is different in 920 12SE-IM when compared to the other model? This is like a premium box. When you talk about the premium box, there are a couple of hardware features which are available on this and then which are needed for the cell-side router deployment specifically. That's the reason we came up on this, and you will not see it in other variants, right? First thing is the CPU that we use. In the other ASR920 variants, we use a 2-core CPU. Here we use a 4-core CPU. The additional 2 cores are being used for services or implementing services like IPsec and NAT. So you will see that IPsec and NAT are supported only on this platform and not any other platform, right? And there is 8 copper ports on the right side, right? So those copper ports, they actually provide PoE support, so you can draw power from those ports. So when you talk about the ports here, right? So we have 4 1 GIGI SFP plus, 1 GIGI 10 GIGI SFP plus. So just below the IM, if you trace from left, there is 4 1 GIGI 10 GIGI SFP plus, and that's a dual rate again, 1 GIGI and 10 GIGI. And we have 4 1 GIGI, just 1 GIGI ports SFP, and we have 8 copper 1 GIGI ports. So there is total of 12 1 GIGI, both copper and fiber combined. And then there is actually 4 ports, dual rate 1 GIGI and then 10 GIGI. And do also make a note, there is an IM slot on top. So that's a 1RU platform. The IM slot can take like TDM, 10 gig, 1 gig interfaces. So, and also another important thing is the GNSS receiver. This has the built-in GNSS receiver. So whereas in RSP3 you could see it was a small module which would go on the RSP3, right? Here it's built in. So the important features on the ASR920 12SDIM, we call it a next generation cell site router because of all these additional capabilities, right? Built-in GNSS receiver, support for IPsec, capability of IPsec and NAT, they are not supported yet, but they're coming up, and also power over Ethernet, right? So these are the 4 important differentiators with the ASR920 12SDIM. Okay, so I'm going to just skip through this. You can just keep it as a data slide for now. So from the timing support, since this router is actually targeted for cell site deployments, this is pretty heavy on timing, right? So when we talk about timing, 1588, ordinary, master, slave, boundary clock, hybrid clock, PMCA, telecom profile 82.1, 8265.1 telecom profile, end-to-end transparent clock, PTP hop-by-hop, boundary clock, ring redundancy. So all the advanced timing features are going to be supported on this platform. GNSS capabilities, this is, again, just to actually talk about what GNSS features do we support. Important things to highlight, I mean, there are multiple types, there are multiple constellation receivers that you can support, right? All those are mentioned here, but it includes GPS as well. It can track up to 32 GNSS satellites, and it has anti-jamming function and also cable delay compensation as well. So people who are really into timing, so they would be able to actually relate about these features more. Okay, I am supported for now. 8 gig RJ45, 8 gig SFP, so in order to increase the gig density on the platform, and the 816 T1E1, and also there is a 10 gig XFP based IM. So we have additional IMs that will be supported on the roadmap. For now, these are the IMs that we are shipping with the 12SC variant. Okay, so we talked about the 920 newest platform. Now it's important to understand licensing. So I want to just give you the licensing framework, and depending on features that are supported on different platforms, the licensing will vary. But the framework is actually constant across all the 920 platforms. So talking about the licensing framework, so you have features that you configure on the box, like layer 2, layer 3, or MPLS. We call that as a technology, and then we divided the licenses into technology packages. There is actually a layer 2. If you have a pure layer 2 based deployment, you can just use a layer 2 package. It's a Metro Access Services package. If you have a layer 3 and layer 2 based deployment, you can use the Metro IP Access Services, right? That has both layer 2 and layer 3 features. If you have layer 2, layer 3, and MPLS, you can use the Advanced Metro IP Access Services license. So the Advanced Metro IP Access Services license has all the features. When we talk about layer 2, layer 3, and then MPLS, it has all the features that can be configured on the box, right? So I'm talking about just layer 2, layer 3, and then MPLS features. Do remember, like timing sometimes, like people call it as an additional feature as well, right? Generally, casually when talking. So if you need to configure boundary clock, like have like a PDP master, then you would need a feature license as well. So which is on the top, let me get there. But I think technology packages are layer 2, layer 3, MPLS. Those are the features that come under technology packages. And then we have port-based licenses. So when you buy a ASR920 by default, like on the 12 port, only 6 ports are enabled. So in order to enable the remaining 6 1 gig ports, right, you need to buy licenses. And also the 10 gig, in order to upgrade the 10 gig ports, the dual rate ports to function in 10 gig, you need a 10 gig upgrade license. And also with the 24 port, it's like the 12 ports, 24 gig ports. The 12 ports are enabled. So to enable the remaining 12 gig ports, you would need a license. So that's how the port-based licenses would work. So we have a pay as you grow. That means that you can just buy licenses. Like suppose you want to actually just enable the 1 gig, you can buy the 1 gig license. And then the future, you want to actually enable the 10 gig license, you can buy the 10 gig license. That's pay as you grow, depending on how your growth in the network actually continues. So if you see the need for all the ports to be enabled in day one, you can buy a bulk license, right? Obviously, the bulk licenses are discounted when compared to pay as you grow licenses. And on top of that, you have the feature licenses. The feature licenses are like your boundary clocks, right? IPsec, GNSS, UPOE, NetFlow. These are all the feature licenses. So when I talk about the framework, do understand this, right? So the technology packages are all your layer 2, layer 3 MPLS, your port-based licenses to enable port, and then you have feature licenses to enable your features like IPsec, GNSS, UPOE, and then boundary clock. So for each and every variant, right, how the licenses work. So I have it in the slides here. I'm not going to go through in the interest of time, but you can read through it. It's pretty self-explanatory. Okay, so talking about the carrier Ethernet ASIC. So the switching ASIC that we use in 920 today is again defined by the carrier Ethernet requirements, right? And so the processing power of the ASIC is 64 gigabits per second. So it can actually process 64 gigabits per second of traffic. And how many million packets per second it can handle? It's 96 million packets per second. So when you talk about oversubscription and all, do keep this in mind. All the ASR920 variants use the same ASIC. And all the ASICs are 64, all the ASICs, the throughput is 64 gigabits per second. I mean, the ASICs used in all the variants, of course, it's the same. So some of the points that you need to actually keep in mind is MPLS labels. The ASIC supports 5-label push, 3-label pop. So customers who are going from like a layer 2 to a unified MPLS, they need like a 4-label push, right, for the unified MPLS-based deployment. And then when they jump to like the next generation, next realm of routing technologies like segment routing or transport technologies like segment routing, then you would actually see these kind of requirements coming to picture. So the ASIC has been actually developed keeping these things in mind, right? That's an important point to note. And also VLAN tag, we do 1 tag push and then 2 tag pop. BFD and CCM 3.3 millisecond for designing fast converging networks. You need the failures to be detected as fast as possible. So BFD 3.3 millisecond helps you to detect a failure within 10 milliseconds. Timestamping, hardware timestamping, with timing being such an important piece in your mobile backhaul network, you need timestamping support in hardware itself. And obviously, when you have timing, you need to do the delay measurements, and then you need to have good accuracy for the delay measurement, right? So the hardware is capable of nanosecond delay accuracy measurement. Today, most of the applications, they use microseconds. They're up to microseconds, micro and milliseconds. So really, the hardware is capable, but when the applications actually, when there is a need for the applications to measure the delay at nanoseconds, so we can implement it in the software since it's supported in the hardware. Okay, so just to touch upon service activation, not to go in great detail, but service activation is traffic generation and also measurement feature. And service activation also covers loopback, service loopback as well. So, right, if there are 2 devices where you're setting up a service like a layer 2 VPN, once the layer 2 VPN is set up, you can send the traffic from one side, loop it back on the other side, and see if it's received back again to check the forwarding path, right? The end-to-end forwarding path works. And then you use service activation because it sends like an actual data traffic, right? So service activation is supported since 3.16, which was a couple of months ago, and we support throughput and loss. Delay and jitter are going to be supported in the future, and we support both layer 2, layer 3, layer 2 and layer 3 traffic generation, and also a combination of multiple packets in layer 3, which is more like an IMIX-based traffic generation. So, and there are actually a couple of other things we can do, like we can do QoS with the traffic generation as well. So I'll just leave it for you to just go through the details on service activation. Next, getting to ASR920 scalability, right? So in terms of scalability, MAC addresses that we support is 16,000 MAC addresses. Ethernet over MPLS pseudo-wires is 2,000, MQ size 90 to 16, just touching upon the important ones. And VPLS instances 2,000, IPv4 routes 20,000, IPv6 routes 4,000, and IPv4 multicast routes is 1,000. These are all like supported at the same time, so it's not like 20,000 IPv4 or 4,000 IPv6. And the number of neighbors that you can have OSPF, ISIS, PGP combined is like 400. Number of MPLS VPNs is 128. So this is where it's important to understand why we have different BFP sessions for different models. The 24-mode model has a bigger FPGA, and that's the reason it is able to do 1,024 BFP sessions at 3.3 milliseconds. The 4-port, 10-port, or the 12-port models, they all do 63 BFP sessions at 3.3 milliseconds. So it's important to understand that the FPGA size dominates this, and the FPGA size only changes the BFP. There is no change in like routing scalability parameters, and also all those, they remain the same. That's it, some QoS. Also, there is a 12 MB internal buffer, and there is always a talk about 12 MB, is it sufficient? So internally, we do like intelligent dynamic queue allocation. So whenever there are microbursts, the platform automatically assigns buffers to the queues intelligently based when the bursts happen within the platform. So that's an important thing to keep in mind. IPSLA session 2024, nothing much here. Software roadmap, 920 has been shipping for the last 1.5 years, so we are caught up with most of the layer 2 topology-based features, layer 3 topology-based features like unified MPLS, some IPv6 like 6P, 6VP. The next 2 or 3 releases, we are going to focus on segment routing. So by next March, we'll have segment routing on ASR920. So you will have a deployable feature set for segment routing, and also a feature set that will help you migrate from an LDP-based network to a segment routing-based network. So 920 is one of those unique platforms that supports all the 3 realms of layer 2 access technologies, right? Not layer 2 access technologies, but all the 3 realms of access to the transport technologies, right? Layer 2 using grep G8032, we support that. Unified MPLS, which is the current one, and then the future transport architectures with segment routing. So that's an important point to highlight, or that's actually a main highlight point in terms of the software roadmap. So I'll just leave it as the as a reference slide for now, for you to actually refer if there are any questions on the roadmap, any features, to get back to me. Okay, so we talked about the access and aggregation, and there is actually one more place in the service provider network, which is NID, right? And we have a platform called ME1200 to support the NID-based deployments, right? So let's take a closer look. The ME1200, it's a 6 GG port, and it's a MEFC 2.0 certified. It supports MEF QoS, and we also have all the layer 2 based feature sets, which mostly is required or a must-have in the NID. SyncKey 1588 support as well is present, and then service activation. So if you want to actually measure your service all the way down to the customer premises, right, you can actually run service activation on ME1200 as well. So now, given the sort of NID deployments that we have, there can be thousands, there can be 10,000 of NID that can be seen in a particular service provider network, right? So the customers, sometimes they ask for a combination of like centralized management or like a distributed management. So what we did was, in order to support both of these deployment models, we we have two ways of actually managing the ME1200. One, you can have an ASR920 or ME3600, and like in an access node can manage an ME1200 ring. That's mostly a distributed one, right? So every NID-based ring or maybe a NID-based network can be managed by an ME3600, by an access ME3600 on ASR920. That's a distributed model. If you need a centralized model, you can have ODL controller. It's obviously we worked on the controller and then we added some APIs to work with ME1200. That's more of a centralized model. It can manage centrally all the ME1200 in the network. So there are two different types of manageable models available for ME1200. So nothing more on ME1200. It has 6 1 GB ports, and I'll just leave the other points as the data points. Power consumption to be noted, it's approximately around 10 watts, really low, right, for a NID. And nothing much here. An important thing is support for timing. So we have SYNC-key, 1588V2, both BC and OC are supported, and then the quality of the clock is Strata 3 on the ME1200. And this is just the software. What are the different types of features that we support on ME1200? Like I said, it's completely layer to focus, which is actually required for a NID, and that's what we have worked on. Okay, finally talking about product provisioning, right? So I know we are already 4 minutes past, so I'm going to quickly talk about product provisioning, and then I'm going to quickly talk about EPN. So those are the last 2 topics. So product positioning, right? So I've been reiterating ASR900 for aggregation, ASR920 for access, right? So in a service provider environment, you will see a core network, and then in the core, classically Cisco core position devices are your NCS, CRS, and then the edge is the ASR900, and then from the edge you will have pre-ag ring, right? So the pre-ag ring, that's where you would actually position your ASR900 boxes. From your pre-ag, there will be access rings hanging off, right? That's where ASR920 will come in. Depending on what type of deployments, access deployments are, right? You would use multiple variants of 920s, right? You need like a 12-port, you need like a 24-port, depending on the need, depending on the consumption, the traffic that is being passed, right? And also the number of subscribers which are there, right? So you would have multiple ASR920 variants. Now, the ASR920 smallest one, so when you have a 10 G NID-based scenario, you need a 10 G NID. The ME1200 supports only only GG interfaces, there is no 10 GG. And if there is a requirement for MPLS all the way to the NID, that's where the smallest ASR920 will come into picture. And when we talk about ASR900 in the pre-ag, right? So we have multiple ASR920s. You have 902, 903, and then 907. Most service provider networks are the pre-ag pack up a lot of access rings. So ASR903, RSP3, ASR907, RSP3. So you could decide between like multiple ASR900 variants which are available. So that's where the product provisioning kinds of stands. So we play in carrier Ethernet and then mobile backhaul as well. I've been beating up on timing. One of the major intentions behind this, we play pretty big in mobile backhaul environment. Okay, so let's talk about EPN. EPN is a solution. EPN is a solution like a service provider solution that Cisco internally we validate. We look at the new technologies. We look at all the we look at all the new feasible and then the most commonly deployed features, right? So it's mostly new from the perspective that we actually take those and see how it helps in consolidating or solving the current network problems, and then how we can deploy it in the customer network. So EPN focuses on a service provider solution. So Cisco actually defines, validates the solution, EPN solution. So in terms of EPN, one thing I would like to talk about, since we talk about service provider networks and then architectures, right? So with ASR920 segment routing, And just to make a point on segment routing, in ASR900 also we're going to be supporting segment routing in the future. I mean, it's on the roadmap. So from the architecture, when I talk about like 3 different runs, like layer 2, which is like the legacy-based access, where it's G8032 rep or even like MST. Sometimes like people still run MST there, and the current generation, the current realm of a layer 3-based architecture, which is unified MPLS, right? And there are actually multiple protocols that you need to run with the unified MPLS today, right? You need an IGP for layer 3 reachability, and then LDP for label switching, and you need RFUPT for fast convergence, and then you have RFC 3107 to connect the domains when you have segmented your networks through multiple IGP instances or IGP areas, right? So it becomes a pain point for a service provider to configure and then troubleshoot these many protocols, right? With segment routing, all these protocols are going to merge into one protocol, a segment routing enabled ISIS or OSPF, right? A segment routing enabled IGP, right? So the fast reroute, the LFA are actually inherently taken care of, and segment routing provides source routing capability. So you can have like one provisioning controller on the top. So it provides a way to migrate toward SCN-based architectures as well, right? You can have one controller on the top, and then you can just program one box with a label stack and say that just follow the label stack to reach a destination, right? So all the multiple protocols which were associated in getting the traffic from one point to the other point are kind of simplified into one single protocol. And also, it gives you the flexibility to have a controller which has a topology or a network-wide view, and then which is able to actually configure and then route the packets or switch the packets across explicit paths, right? You don't need RFC 3107 anymore when you have a controller and then the source routing capability of segment routing. So all these things, they help service providers to simplify their network in terms of operations, in terms of configurations, in terms of troubleshooting, right? And we with ASR900 and 920, we actually are actually leading it by supporting the segment routing features, not just actually to complete the whole segment routing architecture, but also help customers migrate from unified MPLS to a segment routing based architectures. So we are with introduction of segment routing, like the segment routing capability, a completely deployable segment routing will be available in March. That's like 3 or 4 months away from now. So ASR920 is one of those leading platforms where the platform can go into any type of network, be it a layer 2, be it a layer 3, or the next generation segment routing based architectures. So that is actually the important point, right? And the segment routing simplification of transport architectures, they actually take a lot of time in order to explain, right? So this is a big different topic itself. So people who understand segment routing, people who understand the advantages of segment routing, so it's easier for them to kind of understand how the network topology will be simplified. But essentially the important point that I made and then I want to make here again is ASR920 coming next March. You can take ASR920 and also 900 in the future with RSP3, and then you can deploy it in any layer 2, layer 3, or like segment routing based networks. So, and RSP2 today with ASR903, RSP2, the segment routing capability is going to come up in 318 as well. So with RSP2, ASR903, you can have like an aggregation and then an access completely a segment routing based one. And also the Cisco solution of access and aggregation can actually be deployed in any architecture, layer 2 based architecture, layer 3 based architecture, or segment routing based architecture. By that, I would like to actually close out on the session. That's pretty much all I had. I know I had a lot of topics to talk about, but I hope I actually covered everything, if not in a detailed way, at least touching upon the high-level points or the important points.
Thank you, Vinod, and thank you everyone for attending the session. We are all, and sorry, we are pretty, I think we went over time, but once again, if you have any questions, Vinod has shared the email, or you have the email address in the post, you can reach out to me. I have shared the slides and the recording location in the chat window as well as in the Q&A window. So you can copy paste it and you can find the recording, because this is a recording which we did in the morning for 8 a.m. session, and the slides are the same which we have. And I will also post this recording in the same location. All right, thank you everyone.